and welcome, my dear friends. Today the topic is about impurity defects in ionic crystals. In previous video we talked about the stoichiometric point defects, then the non-stoichiometric point defects along with problems. The links have been placed in the description. Now this is the next lecture, that is impurity defects in ionic crystals. What they are all about, let's have a look. Impurity defects are basically those defects wherein foreign ions replace the existing ions in an ionic crystal. So if foreign ions replace the existing ions in an ionic crystal, the defect is called as impurity defect. Impurity defect. So एक ऐसा डिफेक्ट जिसमें हम फॉरेन आयंस को इंट्रोड्यूस कराएंगे, वो फिर रिप्लेस करेंगे the existing ions in an ionic solid or ionic crystal. Such a defect is called as impurity defect. We are not talking about the defects in atomic crystals. This is basically ionic crystal over here. In atomic crystals you are having, suppose, silicon and germanium crystals, covalent crystals. So you are basically introducing in them the impurity like pentavalent and trivalent. So they lead to the formation of p-type and n-type semiconductors. We will not be discussing in this video this part. Rather we only talking about the impurity defects in ionic crystals instead of these atomic crystals. Now let's have the illustration. How can you explain it? Let's have a look. Suppose आपके पास, for example, अगर आपके पास एक ionic crystal है, so you are having cation and anion placed in that particular crystal. Suppose is plus is here sodium, so minus is here chloride, so it's a sodium chloride crystal. So this is a sodium chloride crystal. अगर आप इस sodium chloride crystal में डालेंगे suppose potassium chloride, so what forms is one of the cation, one of the sodium ion that will get replaced by means of potassium. So you will end up with this particular crystal, that is so ये जो जगह थी, यहाँ पे ये जो जगह थी, ये सोडियम की जगह थी. अब ये वाली जगह जो है, it is not occupied by sodium, it is actually occupied now by potassium, K+. So what does that mean is आपके पास जो क्रिस्टल था NaCl क्रिस्टल, उस NaCl में आपके पास कैटाइन्स भी सोडियम थे, एनाइन्स क्लोराइड थे, लेकिन after you introduce potassium chloride into it, one of the sodium has been replaced by potassium. So this is basically a crystal wherein you have rest of the cations as sodium and one of the cation as potassium. So you have introduced a foreign ion into the site of that existing ion. So this is called as a defect, that is the impurity defect. Impurity defect. अगर आप इसमें देखेंगे, इसमें कोई भी vacancy create नहीं होगी. So the charge of sodium is +1, so charge of potassium is +1, so there is no cation vacancy produced in this particular case. Now अगर आपके पास ये है, suppose you are having again an ionic crystal, you are having again an ionic crystal, and again we say that it's plus that sodium over here and it's minus that is chloride over here, which means this is the crystal which is basically the sodium chloride crystal. ये एक sodium chloride crystal है. अब अगर आपने इसमें इंट्रोड्यूस कराया है strontium chloride, if you use strontium chloride as the doping substance or impurity, so strontium की valency जो है that is strontium 2+, लेकिन sodium का जो valency है that's Na+. So it means that you require one strontium 2+, you have to replace 2 sodium ions because to neutralize the crystal. So what forms is you are having this particular crystal, then it's plus, it's minus, it's minus, it's minus, it's plus, then again it's minus, and over it's plus, then you have plus, minus, and it's again here minus. So ये जो जगह थी यहाँ ये वाली जगह, this is the place of sodium and this is actually the place of sodium, but once you introduce strontium into it, you are having here strontium 2 plus for instance. तो यहाँ पे जो जगह थी सोडियम की ये ऑक्यूपाई की स्ट्रॉन्शियम ने, लेकिन उसका चार्ज जो है वो 2 प्लस है, तो 2 सोडियम आपको निकालने ही है टू मेक द सिस्टम न्यूट्रल. देखिए अगर आप यहाँ पे देखेंगे इसमें टोटल कैटाइन्स 6 है, 1 2 3 4 5 6, एनाइन्स भी 6 है, 1 2 3 4 5 6, so 6 anions and 6 cations are there, but in this particular case you are having 6 cations as well as 6 anions, so it's neutral. अब देखिए एक कैटाइन और ये 2 हो गए 3 4 5 और 6, एनाइन भी 1 2 3 4 5 6, सो बराबर है. लेकिन इसमें जो है इसमें एक वैकेंसी क्रिएट हुई, वो कैटाइन की वैकेंसी है. सो इट मीन्स दैट अगर आपने चार्ज डिफरेंस अगर होगा, व्हेन देयर इज चार्ज डिफरेंस, सो यू आर बेसिकली क्रिएटिंग cation vacancy. So point to be noted is this is the defect also called as impurity defect. This is the defect also called as impurity defect. The reason is you are introducing a new ion that replaces the existing ion from its lattice site. So this defect is called impurity defect. लेकिन पहला जो एग्जांपल मैंने दिया है इसमें चार्ज जो है existing ion का और चार्ज जो है impurity ion का, that is same, so there is no cation vacancy producer. अगर आप इसमें देखेंगे charge of existing ion is different from that of the impurity ion, so there is one vacancy, one cation vacancy producer. So we can write over here that so cation vacancy जो है that will be equal to cation vacancy बराबर होगा charge of impurity ion minus charge of existing ion. So cation vacancy जो है that is equal to charge of impurity ion minus charge of existing ion. For example, अगर आप यहाँ देखेंगे, for example, if we just talk of this particular case, so cation vacancy in first case, that is in this case, is equal to existing ion, impurity ion की charge क्या है, +1 है because it's potassium, so it's 1 minus charge of existing ion क्या है, it is sodium, it's having again one charge, so 1, that is 0. So there is no cation vacancy produced in case of this particular case. Now in the second case, if I just talk of this particular case, next one, तो इसमें cation vacancy कितने आएगा, that is equal to charge of impurity, that is strontium 2 plus, that's 2 plus, that means 2 minus charge of existing, that's 1 cation, that's equal to 1. So there is one cation vacancy producer that's shown here. इसका मतलब ये हुआ अगर आपने एक मोल अगर आपने एक मॉलिक्यूल स्ट्रोंशियम क्लोराइड का डाल दिया इन एन आयनिक क्रिस्टल, तो cation वैकेंसी B कितनी निकलेगी, एक ही निकलेगी. So charge difference gives you the cation vacancy. This implies 1 mole of strontium chloride जो आपने डाला in a sodium chloride, that gives you 1 mole of cation vacancy. Because cation vacancy 1 निकली जब आपने 1 मोल strontium chloride डाला था. So 1 mole of strontium chloride produces 1 mole of cation vacancy. This is the result we obtained from this particular case. So you have to subtract the charge of impurity minus the charge of existing ion, you will get the number of cation vacancies. I hope you understand it. Now, one more point I should add here is, now how can you find a cation vacancy? How can you find cation vacancies in an ionic crystal? So for that we are having a formula, that is, so number of cation vacancies can be obtained as तो आपके पास नंबर ऑफ कैटाइन वैकेंसी किसके बराबर होगा, दैट इज इक्वल टू QD NA and NI. So this is the formula which you can use to find the number of cation vacancies in an ionic crystal. So this is the number of cation vacancies, and QD is basically the charge difference. Charge difference, which is basically the charge of this impurity ion minus the charge of existing ion. That is charge difference, and NA is the Avogadro's number. that is equal to 6.023 into 10 to power 23, and now Ni is basically the moles of impurity ion. Moles of impurity ions. कितने moles impurity ion आपने डाल दिए हैं in that ionic crystal. So this is how you can obtain the number of cation vacancies in that particular crystal in which you basically dupe the impurity ions. So let's take some problems to further explain it. So हम question लेंगे. Question number 1 हम लेंगे. If sodium chloride crystal is doped with 10 raised power minus 3 mole percent of strontium chloride, find the number of cation vacancies. आपको cation vacancies निकालने हैं या concentration of cation vacancies निकालनी है in that ionic crystal in which you dupe strontium chloride having this mole percent. So आप कैसे निकालेंगे? आप डायरेक्टली इस्तेमाल करेंगे what? Formula is number of cation vacancies is equal to QD charge difference into Avogadro's number into number of moles of impurity. ठीक, अब QD आपको पता है, QD is the charge difference. आपके पास सोडियम क्रिस्टल था, आपने इसमें डूप कराया स्ट्रोंशियम 2+ का, तो 2 + 1 माइनस कितना डिफरेंस हुआ? 1. डिफरेंस 1 का हुआ. सो QD इज इक्वल टू 1. Na you know Avogadro's number of moles of impurity. देखिए यहाँ पे दिया हुआ है क्या? मोल परसेंट. इट्स गिवन हियर मोल परसेंट नॉट मोल. सो मोल परसेंट किसके बराबर होगा? सो moles of strontium chloride will be equal to, that is 10 to power minus 3 divided by 100, because its mole percent means moles of strontium chloride will be equal to 10 to power minus 3 divided by 100. So this gives the moles of strontium chloride. So put the value here, you will get the answer. So we have number of cation vacancies will be equal to, in this particular case is charge difference is 1 multiply 6.023 into 10 to power 23 multiply number of moles of impurity, that's equal to 10 to power minus 3 divided by 100, that's 10 to power 2, which is equal to 6.023 into 10 to power 23 multiply, ये ऊपर जाएगा, it becomes 10 to power minus 5. So we have the answer, that is 6.023 into 10 to power 18. This is basically the number of cation vacancies produced when you dupe 10 to power minus 3 mole percent of strontium chloride in NaCl crystal. I hope you understand it. Now next question हम लेंगे. So question number 2 is, if 10 to power minus 5 mole percent of AlCl3 is doped in NaCl crystal, find the number of cation vacancies. सीधी सी बात है, आप डायरेक्टली फॉर्मूला इस्तेमाल करेंगे. सो नंबर ऑफ cation vacancies will be equal to charge difference into Avogadro's number into number of moles of impurity. This is the expression you often use. Now we will write over here. So number of cation vacancy will be equal to charge difference कितना है? देखिए अल्युमिनियम है यहाँ पे, सो अल्युमिनियम 3+ है यहाँ पे, जो हम डूप कर रहे हैं किसमें? सोडियम क्लोराइड क्रिस्टल में. तो Na का चार्ज जो है +1 है, तो 3 में से 1 काटो तो 2 बन गया, मतलब चार्ज डिफरेंस कितना निकला आपको? QD, that's 2. So you have 2 multiply Avogadro's number is 6.023 into 10 to power 23 multiply number of moles of impurity. लेकिन दिया क्या है? मोल परसेंट. सो नंबर ऑफ मोल्स किसके बराबर होंगे? -5 divided by 100. This will be equal to 12.046 multiply 10 to power 23 multiply 10 to power minus 7. So this will be equal to 12 into 12.046 multiply 10 to power minus 10 to power 16. So this is the answer. इतने नंबर ऑफ cation vacancies प्रोड्यूस होंगी जब आप 10 to power minus 15 मोल परसेंट सिल्वर, ये जो अल्युमिनियम क्लोराइड है, डूप करेंगे इन NaCl क्रिस्टल. इन द सेम वे अगर आप यहाँ पे देखेंगे क्वेश्चन, सो हमारे पास क्वेश्चन नंबर 3 है, दैट इज इफ 10 to power minus 3 mole percent of NaCl is doped in KCl crystal, the number of cation vacancy is. cation vacancy को निकालने हैं, सीधी सी बात है. The formula is QD, Avogadro's number and number of moles of impurity added. आप देखेंगे QD is equal to 0. QD is equal to 0 कैसे? कैटाइन की चार्ज जो है +1 है. अब एनाइन जो इम्प्योरिटी ऐड कर रहे हैं उसका भी +1 है. 1 minus 1 is 0. चार्ज 0 है तो देयर इज नो कैटाइन वैकेंसी एट ऑल. ये मैंने पहले भी आपको बोला, क्या अगर आप चार्ज डिफरेंस अगर 0 होगा जो आप इंट्रोड्यूस करेंगे तो डिफेक्ट तो होगा लेकिन वैकेंसी क्रिएट नहीं होगी कैटाइन की. This is how you find the number of cation vacancies, and this is what is called as the impurity defect in ionic crystals. So this is all about for today. I hope you understand it. If you like my videos, please do not hesitate to share and subscribe my channel. Watch it carefully, make notes, and like, comment, and subscribe. Till then, take good care of yourselves. Thank you very much.